Hello friends, we have already discussed 3 examples of question number 5 of exercise 8.4 chapter number 8, that is trigonometry. Now let us start example number 4. The 3 examples, they are on the basis of the conversion formula as well as the fundamental identity of trigonometries. We have already solved 3 examples. Now let me start 4th example. The title of this example is prove the following identities. We have already proved 3 identities. Now let me start 4th identity. The 4th one is 1 plus sec A upon sec A is equal to sin square A upon 1 minus cos A. You know, there are many ways to prove an identity. You can take LHS, use different formula and get RHS. Similarly, sometimes you can take RHS, use formulas, identities, and then you can prove LHS. So in this example, let me take RHS. So what is your RHS? Sin square A upon 1 minus cos A. Now multiply. So you can say sin square A is equal to 1 minus cos square A, because you need sec A. But sec and cos are the inverse of each other, reciprocal of each other. So sin square means 1 minus cos square A upon denominator 1 minus cos A. You can divide 1 minus cos square A into 2 parts. 1 minus cos A, 1 plus cos A upon 1 minus cos A. You can cancel 1 minus cos A, so the remaining term is 1 plus cos A. But you need 1 plus sec A upon sec A. So you know one conversion formula. You can easily convert cos into sec, because cos theta is equal to 1 upon sec theta. So 1 plus 1 upon sec A, if you cross multiply, you get sec A plus 1 upon sec A, and that is your RHS. Very simple example. Just use sin square A is equal to 1 minus cos square A. Then in place of cos A, you write 1 upon sec A. So 1 upon sec A is equal to cos A, reciprocal formula. Here you can use identity sin square theta plus cos square theta is equal to 1. Therefore 1 minus cos square theta is equal to sin square theta. Well, now let me start example number 5. Cos A minus sin A plus 1 upon cos A plus sin A minus 1. Let me take LHS. Cos A minus sin A plus 1 upon cos A plus sin A minus 1. You need cosec A as well as cot A. Cot means cos upon sin. So divide numerator as well as denominator by sin A. So here you get cos A upon sin A minus sin A upon sin A plus 1 upon sin A. Similarly, in the denominator, if you divide by sin A, what you get? Cos A upon sin A plus sin A upon sin A minus 1 upon sin A. Now we know cos A upon sin A is equal to cot A. Sin A upon sin A means minus 1 plus 1 upon sin A means cosec A. Similarly, in the denominator, cos A upon sin A means cot A plus 1 minus cosec A. Now you know your answer, your RHS is cosec A plus cot A. But here you can't have cosec A plus cot A. So multiply the given identity, given procedure, multiply by cos A plus cot A. So the numerator is cot A minus 1 plus cosec A into cot A plus cosec A. Similarly, in the denominator, cot A minus cosec A plus 1 into cot A plus cosec A. Now, numerator as it is, so cot A minus 1 plus cosec A, cot A plus cosec A in the denominator, if you multiply this, means cot A plus cosec A with cot A plus cosec A. Here it is A minus B. Here it is A plus B. If you multiply these two, you get A square minus B square, means cot square A minus cosec square A. And then you have to multiply it with 1. So again you get plus cot A plus cosec A. Very important step. First you have to multiply cot A plus cosec A with cot A minus cosec A. Then you have to multiply cot A plus cosec A with 1. So you get cot square A minus cosec square A plus cot A plus cosec A. Now you know, according to identity, 1 plus cot square is equal to cosec square theta. Therefore, cosec square minus cot square is equal to 1. And that's why cot square minus cosec square is equal to minus 1. So in place of this, write down minus 1. So the remaining part is numerator as it is, cot A minus 1 plus cosec A into second bracket cot A plus cosec A. Here when you write minus 1, this become minus 1 plus cot A plus cosec A. You can cancel these two. So what you get? Cot A plus cosec A, and that is your RHS. So you have to take care in this step. When you multiply these two things and then you have to use difference of 2 square, then you have to use one identity, and that is cot square minus cosec square is equal to minus 1. Well, now let me start example number 6. Under root 1 plus sin A upon 1 minus sin A is equal to sec A plus 10. Now LHS is 1 plus sin A upon 1 minus sin A. Now multiply and divide by conjugate of 1 minus sin A, that is 1 plus sin A. So numerator is 1 plus sin A upon 1 minus sin A multiply by 1 plus sin A upon 1 plus sin A. So in the numerator 1 plus sin A whole square, in the denominator A minus B, A plus B, according to the identity A square minus B square, so 1 minus sin square A. So in the numerator 1 plus sin square under root, and that's why you can write 1 plus sin A. 1 minus sin square means cos square A, and square root of cos square A means cos A. So your final answer is 1 plus sin A upon cos A. Now you can divide this into two parts. Therefore 1 upon cos A plus sin A upon cos A. So 1 upon cos A plus sin A upon cos A. 1 upon cos A means sec A, and sin A upon cos A means tan A. So this is your RHS, and that's why sec A plus tan A is your answer. Very simple example. Now let me start 7th example. Sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta. So you can take sin theta common from the numerator as well as cos theta common from the numerator. From the denominator. So sin theta common from the numerator, sin theta into 1 minus 2 sin square theta. If you take cos theta from the denominator, you get 2 cos square theta minus 1. Now, you know, there is one identity, fundamental identity of trigonometry, that is sin square theta plus cos square theta is equal to 1. So now in place of 1, write down sin square theta plus cos square theta, you will get your answer. So in place of 1, let me write down sin square theta plus cos square theta minus 2 sin square theta as it is. Same way in the denominator, cos theta in common, 2 cos square theta as it is. In place of 1, when we write sin square theta plus cos square theta, this become minus sin square theta minus cos square theta. So sin theta as it is, cos square theta and sin square theta minus 2 sin square theta means minus sin square theta. Similarly in the denominator, cos theta in common and 2 cos square theta minus cos square theta means cos square theta and minus sin square theta. You can cancel this. So you get sin theta upon cos theta, and sin theta upon cos theta means tan theta, and that is your RHS. Well friends, in this trigonometry, we have taken 11 lectures for exercise number 8.1, 8.2, 8.3, 8.4. In first and second period, we have discussed different formulae of trigonometry, and those formulas are very important to solve any example. Then we have discussed exercise number 8.1, that is on the basis of the formula of sine theta, cos theta, tan theta, cot theta, sec theta and cosec theta, that is reciprocal formula. Then we have discussed 8.2, and that is on the basis of the value of the trigonometric functions for different value of theta. Then we have started exercise number 8.3, and it is on the basis of sine 90 minus theta is equal to cos theta, cos 90 minus theta is equal to sine theta. Similarly, tan 90 minus theta and cot 90 minus theta is equal to cot theta and tan theta respectively. Similarly, sec 90 minus theta is equal to cosec theta, and cosec 90 minus theta is equal to sec theta. Then in exercise number 8.4, we have solved 7 examples to prove how to prove an identity, how to use fundamental identity of trigonometry in different examples, and to derive from LHS to RHS. You know, there are 10 to 11 examples in this exercise. I have already solved some examples. The remaining 3 examples is homework for you. With this, we end this chapter, that is trigonometry, and very useful chapter for 10th standard as well as those who want to take admission in 11 science. For those, this chapter trigonometry is very important. So let me complete this chapter, chapter number 8, and next lecture we will start another chapter. Thank you friends. Thank you.